Good evening, everybody. I welcome all the students to Pune College of Arts, Science and Commerce Camp Pune 1. I teach statistics at FYBSc and FYBA level. The course title is Discrete Probability and Discrete Probability Distributions. Myself, I am Dr. M.B. Pathan. In last lecture, we tried to solve some numerical examples related with probability mass function and probability distribution. We learned from that examples how to decide unknown constant k in given probability distribution or in given PMF. Today, we'll try to proceed ahead to the new topic under the heading of cumulative distribution function. It is also labeled as CDF. Sometimes it called as distribution function only and denoted by capital F. It is compulsory capital F. There is a difference between probability distribution and distribution function. To explain today's topic, I can take a help of paper 1, that is a descriptive statistics. In descriptive statistics, you already studied concept of cumulative frequency distribution. The calculation of cumulative frequency distribution and cumulative distribution function exactly parallel. In cumulative frequency distribution, we add successive frequencies from beginning to end, and the last number comes to be capital N as a total of frequencies. Here also the same thing happening. Instead of adding frequencies, we add respective probabilities. And we keep on adding probabilities successively till the end of data, and the last, it should be 1 because total of probability is 1. What I'm trying to explain is the similarity between these two topics, cumulative frequency distribution and cumulative distribution function, or you can call cumulative probability distribution. Simply, it also known as distribution function, always denoted by capital F, be remember. Now, how to write definition systematically? It is like this. If capital X is a discrete random variable with PMF Px, P bracket small x, then the distribution function of capital X is given by. Now, this is the most important part of the definition to be remembered. What the definition says, capital F bracket small xi equal to probability capital X less than equal to small xi. I takes value from 1, 2, 3 up to n. You can see now this is simply calculation of probability, which is less than equal to type. This type of calculation we did in previous lecture. Calculation of probability for variable x less than equal to particular value of x. So what is here? This number is taken inside probability. F of 2 will be probability x less than equal to 2, and so on. I can write this definition in terms of individual probability. So, j from 1 to I, pj. For example, f of xi will be p1 plus p2 plus dot dot, here plus sign pi. So add the probabilities till the value under study. This is known as distribution function. How it is cumulative? Cumulative means successive addition. If I ask f capital for x1, first value of x, answer will be p1. What is f of x2, second value of x? It will be p1 plus p2. So, successive addition took place. F of x3, add the probability up to 3. And it continue like this. That's why this function is called cumulative distribution function. You are keep on making additions as you are going away from first value to the last value. It is just like our passbook balance. When we open the account in a bank with some initial amount, then that initial amount display on the passbook. If you add money in the bank account, previous balance is added with coming deposit and that total is written in front. Similar calculation you have to perform for getting a cumulative distribution function abbreviated as CDF. We have certain properties for this function, which is very important. Many often ask in exam. Properties of distribution function. Number one, it is defined for all real values. That means you can calculate value of capital F for any real number, not necessary for your variable under study, but you can get capital F from minus infinity to plus infinity. That is a property one. Property number two says it is non-decreasing function of x. Now, what do you mean by non-decreasing? Non-decreasing is similar to non-negative concept. If I say x is a variable taking non-negative values, that means my x begin from 0. If I say positive, then x equal to 0 not included. In the similar way, if I say function is non-decreasing, that means I will not say increasing. Increasing is different and non-decreasing is different. Non-decreasing has two possibilities. It may be increasing sometime it may remain constant. So function, if I try to draw the graph by taking value of x on x-axis, and if I try to draw the graph, your function will be increase, sometime remain constant, then sometime again increase. So this is called as non-decreasing function. From here to here, it is a constant parallel to x-axis. Again, this increase. This increase from here to here. So your capital Fx of this nature. That's why it is called non-decreasing. Third property says, it is explained by other notation. If x1 less than equal to x2, then capital F x1 less than equal to capital F x2. Third property, it lies between 0 and 1. That means for every value of x running from minus infinity to plus infinity, the value of capital Fx is between 0 and 1. Why it is so? It is because capital F is a probability, and probability always between 0 and 1. Number 4 property, it becomes 0 by taking sufficiently small value of x, that is capital F with minus infinity equal to 0. Does it necessary to go up to minus infinity? Answer is not. I will explain all these 7 properties with one numerical example to understand clearly. Property number 5, it increases to 1 by taking sufficiently large value for capital X. And the meaning of this, capital F with infinity equal to 1, but not necessary to go up to infinity. It reached to 1 before infinity also, and that is the meaning of sufficiently large. Now to get a 0, it is not necessary to reach minus infinity. It attains 0 before that by taking a sufficiently small value. So what is a sufficiently small? What is a sufficiently large? This I will explain with numerical example. At this stage, just remember f with minus infinity 0, f with plus infinity 1. That means limiting value of capital F on the right hand is 1, limiting value of capital F on the left hand is 0. It is a step function having jump at each value of x. So if you draw the graph of capital Fx with value of x, it looks like a step functions. That means if you try to draw a graph by taking value of x on x-axis, y on fx on y-axis. So what you will get? You will get probabilities like this. This is for x1, then this is for x2, then this is for x3, and so on. That means between the values of variable, fx remain constant. For x1, this is your f. When it reaches to x2, x2 is not here, x2 goes here. It will remain constant till next value of x, that is x3. If it touch to x3, it takes a jump. So if you now look from the left hand, it is just like a staircase. And that's why function is called as a step function. And having jump for each value of x. For x1, this is the jump. For x2, this is a jump. For x3, this is a jump, and so on. Property number 7, probability capital X greater than A less than equal to B equal f of B minus f of A. So I can use capital F to calculate a probability that variable x is in the interval. But be remember, interval should be closed from upper side and open from the lower side. Then answer of this probability will be given by subtraction of 2 capital F. So this is your properties of distribution function. Very important. I put a question on this topic. What is the question? Define distribution function, sometime cumulative distribution function of a discrete random variable. State its important properties. So you have to write a definition and then just write properties, no explanation. State means just you have to write the statements, not necessary to explain. Now we have second concept, that is a median. Median of discrete random variable. Now in paper 1 and in paper 2, the same titles are used. You studied median in paper 1 also in descriptive statistics. The concept is similar. That is related with frequency and this is related with probability. If I go by paper 1, by descriptive statistics, median is nothing but middlemost observation
N/2.
of given data. Median is not n/2. Median is a location at n/2. Suppose I have 100 observation, then median is not 50. Median is 50th value in order data. So be clear about concept. Median is a location and n/2 is a location of that number. So you have to decide value of variable which divides entire data in two equal parts, 50% observation below and 50% observation above. That point is called as a median. So we pick up this concept to define median in paper 2 related with random variable. Now when I say random variable, there is a concept of probability. And when I say only variable, there is a concept of data. So how I define? The value of discrete random variable x which satisfies following two conditions. Number 1, probability x less than equal to median greater than equal to half. So when I put a probability less than equal, that means it is capital F. So value of capital F should be equal or greater than 0.5. What is the next condition? Probability of x greater than equal to median is greater than equal to half. Now look these both conditions. What paper 1 says exactly written in paper 2. The calculation below and calculation above at this point should be greater than half. What paper 1 says? Number of observations below median is 50%. Number of observation above that median is 50%. Now this 50% converted in probability as 0.5. So calculation of probability below median and above median should be equal, that is 0.5. So any value of x which satisfies these two conditions at a time, that value of x is called median and abbreviated as ME. We have next concept, mode of discrete random variable. Again, mode is taught by paper 1 teacher. What is mode? Mode is the value which repeat more frequently, has more repetition, having a maximum frequency. That is called as a mode. So how I can define mode for paper 2, that is for random variable? The same concept. I write probability word in place of frequency. The value of discrete random variable with maximum probability is known as a mode. So this word is important in the definition. In given distribution, you have to decide which value has maximum probability. That value is called as a mode. In given distribution, you have to decide which number gives probability half below and half above. So calculation below and above, that point is nothing but a median. We have the last topic, theoretical, and then we proceed for the numerical problems. Probability distribution of function of new random variable. Suppose x is original random variable under study with PMF Px. Now with the help of x, I define a new variable y as a function of x. Suppose y equal to f bracket x. Then I am interested to decide probability distribution of y by using a knowledge of x. That is the meaning of topic, probability distribution of function of new random variable. What the statement says? Statement says probabilities of x and probabilities of new variable y defined by using x, both are equal. So probabilities remain same, only value of the variable x will change to the value of variable y under this function. I elaborate this concept with a tabular form. Suppose this is my probability distribution of x. X taking value x1, x2, dash dash xi, dash dash xn. x1 has a probability p1, x2 has p2, and so on. Suppose now I define new variable y equal to fx. It may be any function, but it should be 1 to 1. That means for given x1, there should be unique y1. For given x2, there should be unique y2. So fx is nothing but 1 to 1 correspondence. Then probability distribution of capital Y is y values and p of y. If you look these two tables, you can observe that I have not changed the notation of probability. The same notation I carried. That means it says probabilities are remain same. No change in the probabilities. But value of variable will be changed. Suppose I write x equal to 1, 2, 3. and I write y equal to 2x. So for x equal to 1, y will be 2. X equal to 2, y will be 4, and so on. So you have to change only values of variable, not the probabilities. So B, remember, the answer of probability distribution for new random variable, change only values of x to y under given function, but keep the probabilities of original x same as new values of y. So today I will stop with this theoretical concept. Next time I will take different numerical examples related with today's topic. Before to stop my class, I will revise again. I start with the concept of cumulative distribution function, which is also known as a distribution function. It is written as capital F bracket xi equal to probability capital X less than equal to small xi. This is nothing but addition of probability in the cumulative form. After this, we have seen 7 properties of distribution function. Then concept of median, concept of mode, and lastly, how to develop probability distribution of new random variable as a function of older